Okay, in this video, I'm going to be discussing the first of the videos on chapter 3, which deals with matter and energy. And the topics we're going to be covering are how to classify matter, that would be this video, 3.1. And then in the later videos, I'll be talking about states and properties of matter, temperature, scales, all the three temperature scales, energy, and then energy nutrition, especially calories, etc., the nutritional calories, and how to determine that, and then define specific heat, and then change of heat, changes of state, and the heat changes during changes of state. Okay. All right. So here in this picture, you have a dietitian who's taking some measurements, and the dietitians uh, talk about diets based on what your requirements are in terms of calories and how to balance your diet. Okay. All right, so some of the math skills that will be carried over, especially from chapters 1 and 2, are again positive, negative numbers, equations, interpreting graphs, scientific notation, and then the rules of rounding off. And then sig figs, and using those sig figs in calculations, as well as writing the conversion factors, which you learned from chapter 2, and then using of those conversion factors in problem solving. Okay, so this video is mainly dealing with section 3.1, and that's the classification of matter. So matter is, as we defined before, is anything that has mass and space, which is volume. So mass and volume define matter, all right? So there's a particle nature, a material, a nature to matter. And matter can further be classified into pure substances and mixtures. So there's just two types of matter. If it is not pure, it's a mixture, all right? And most matter that we encounter in our life is a mixture, okay? And then pure substances are either elements or compounds, all right? So elements is going to be just something like aluminum foil. It's just one thing, all right? The foil is made up of aluminum atoms and nothing else, all right? Or a copper wire. It's going to be just copper atoms. So that's pure, elements are pure. And then when elements combine in definite ratios, like when they form compounds, that's also considered pure, all right? Like water is H2O. So two hydrogen atoms and one oxygen combined. So there's a definite ratio. H2O2 would be two hydrogen atoms and two oxygen atoms. So there's a very definite ratio in which those elements are combining. There are bonds, chemical bonds, holding these atoms together, and therefore that's considered also a pure substance. Now, mixtures are where things are mixed together, but there's no kind of definite ratio or proportion in which the mixing happens, all right? So, for example, if you mix a teaspoon of sugar in your tea, again, there's no chemical bonding being formed. There's no set formula for that mixture. You could have easily mixed in 2 teaspoons of sugar and it would still be a mixture, all right? So, and the key difference is when it's a mixture, we can separate out the components of a mixture by some kind of physical methods, all right? Whereas in a compound like H2O, to separate out the hydrogen from the oxygen, we would require a method which was not just an ordinary physical method. It would require the breaking of bonds, which would be more chemical method. Energy needs to be expended to break bonds, all right? Whereas in mixtures where the components are not bonded, then it's easier to separate out those components. Homogeneous mixture is where the components have a uniform mixing, all right? So that it's hard to tell between the components, all right, because it's so mixed in so well uniformly. Whereas if it is heterogeneous, like the picture shows here, copper pennies in water, you can clearly see the phase difference between the pennies and the liquid water, all right? So that would be a heterogeneous mixture. So pure substances have fixed or a definite composition, like I explained, H2O or H2O2 or NaCl. There's a fixed ratio in which those elements are combined together to form a compound, all right? Or else just pure elements, all right? Like the aluminum foil or the copper wire example, all right, where there's just one thing making up that substance. Mixtures, on the other hand, have two or more substances. They could be mixtures of elements, or they could be mixtures of elements and compounds, or they could be mixtures of compounds. They're physically mixed, but there's no chemical bonds holding them together. So a pure substance is either an element, which means it's just one type of compound, like here, this the top of this aluminum can, you can see it's made up of just the aluminum atoms, all right, just one thing. Or a compound where there are two or more elements combined together in a definite proportion, as I explained with H2O and H2O2. So elements are pure as they have one type of material, whether so most metals, copper or lead, aluminum or gold, all of those, when they have just one type of material, then it's a pure substance. Compound, on the other hand, has two or more elements combined in a definite ratio, like H2O2. As you can see from the picture, there's two oxygens. The red particles are the in this particle diagram. The red particles are the oxygens, and the grayish particles are the hydrogens, all right? So there's two oxygens and two hydrogens in one molecule of H2O2. And then NaCl is one Na and one Cl. And then sugar has these definite ratios of carbon, hydrogen, and oxygen. That's what makes it sugar, and so on, all right? And so these are chemically held together. There are chemical bonds, and to separate them out would require a chemical process to separate out the individual elements. So here you see table salt. It's chemically formed from sodium metal, which kind of looks like this, a solid shiny metal. And then you have chlorine, which is a gas, which exists in nature as two atoms of chlorine, a greenish gas. So the sodium metal and the Cl2 gas come together and they form the sodium chloride, which is table salt as we know it, okay? So if you break the NaCl down by a chemical process, then you can get back your sodium and your chlorine. So in a mixture, on the other hand, for example, if you have a precipitate in water, right, you can simply filter out that solid onto the filter paper using a funnel. So you are using a physical method to separate out the liquid from the solid, all right? Or sandy water, muddy water. You can just filter out the mud from the water, all right? So in a mixture, you can use some kind of physical method, whether it's evaporation or filtration to separate out the components of a mixture. So a homogeneous mixture is where everything is uniformly mixed in, like the sugar mixed into your tea, or salt water, where you can't really tell salt water apart from just ordinary water without the salt, all right? Because they're both colorless and they both are clear, transparent to light. So you can't really tell the salt is dissolved into that water because it looks just like any other water. All right, so that's called a homogeneous mixture. And so brass or a copper penny, the modern copper pennies have zinc in them, and these kind of when you have two metals mixed in, they're called as alloys. So in alloys, they're homogeneous mixtures of elements, and you cannot tell one element apart from the other, because if you just look at brass, you cannot tell what part of the brass is copper or what part of it is zinc. It's uniformly mixed in. Okay. A heterogeneous mixture, on the other hand, you can tell the components because there is a visible difference between the components making up that mixture. All right, some breathing mixtures are nitrox, heliox, and trimix, and these are used for scuba divers, all right, in order to keep their pressure the same as the pressure that they are when they're underwater. In a heterogeneous mixture like you see here, some pennies put into a glass of water, you can see the difference between the pennies and the water, the phase difference visibly. And so this is a heterogeneous mixture. Muddy water would be a heterogeneous mixture. Milk of magnesia would be a heterogeneous mixture. Salad dressing, where you have to shake it to have everything evenly mixed in, because when you leave it standing, all the stuff comes and settles down. Okay, so there's a phase separation between the phases of the solid from the oily liquid part. All right, okay, so when you can visibly see a phase a difference when you leave something, a solution standing, and things come out of solution, then that's a heterogeneous mixture. All right, so here you have just matter, pure, and mixtures, elements, just one thing, one kind of atom. And you have a compound, which is a combination of atoms chemically combined in definite ratios. You have the homogeneous mixture, where things are mixed in, but you really can't tell visibly the composition of that mixture because the components are so well mixed in. All right, heterogeneous, visibly you can tell what the components of the mixture are because you can see a phase difference between the components of the mixture. So identify each of the following as pure or mixture. Pasta and tomato sauce, that would be a mixture. Aluminum foil is pure, helium is pure, and air is a mixture. Identify each of the following as homogeneous or heterogeneous. Hot fudge sundae. So here you can really see the fudge on top of that sundae. So visibly you can see a difference. That would be heterogeneous. Shampoo, unless things are coming and settling down in your shampoo, it would be homogeneous. Sugar water would be homogeneous. Peach pie, you can see the different components making up the pie visibly, and so that would be a heterogeneous mixture. All right, answer questions 3.1 through 3.6 on page 66, and that is the end of this video.